Yes, it is finally here. We have access to some of the most advanced hitting data imaginable. MLB organizations have had this access for a while now, but we, the public, finally get to play around with this info. And no, don't worry, I'm not becoming a hitting guy. The reality is that a lot of hitting statistics are really just pitching statistics in disguise. So in this video, let's dig into everything Statcast just released, from contact point to attack angle and everything in between. What we're looking at here are the three pillars of advanced swing analysis. The first is attack angle, the second is vertical bat angle, which Statcast is calling swing path or tilt, and the third is contact point, or what Statcast is calling attack direction. Let's start with attack angle. Statcast is defining this as the vertical angle at which the bat is traveling as it impacts the ball. When you zoom out and look at all swings, the MLB average for attack angle is right at 10 degrees. This includes guys like Christian Yelich and CJ Abrams. The low range includes guys like Jacob Wilson, Xavier Edwards, and Vladimir Guerrero Jr. Yes, probably the most surprising thing here is that Vladdy actually has one of the flattest attack angles to the baseball on average. The guys with some of the most upswing on average are Eugenio Suarez and Max Muncy. One thing to note here is that attack angle is very dynamic, so it changes throughout a hitter's swing, which is really easy to visualize when you look at one of these Statcast graphics that shows that red line indicating the attack angle throughout the flight of a hitter's swing. One coach I talked to actually said that when you get to zero attack angle in a swing is a way to kind of fingerprint a hitter. A lot of guys are around that same point. But the reality is we're not going to get total access to dynamic attack angle. What we're looking at here is just point of contact attack angle. With a lot of the information we talk about here, these numbers are going to change based on the incoming pitch. So attack angle will change based on the location of the ball in the zone as well as the pitch type. And both of those obviously are not unrelated to one another. Statcast also has a metric known as ideal attack angle, which I think is roughly a way to measure that length of a hitter being on plane that I was just mentioning. In Mike Petriello's article breaking this all down, he showed that an ideal attack angle, so between 5 degrees and 20 degrees, creates on average about 130 points more slug and 60 more points of expected weighted on base. And when we look at the leaderboard for ideal attack angle, we get a mixed bag of hitters, mostly good, guys like Corbin Carroll and Juan Soto, but also some not so great like Brenton Doyle and Luis Garcia. I kind of wonder whether this is some proxy for a consistent swing that maybe needs to be layered with swing decisions and pitch location to really get the full punch. Next, we have tilt or vertical bat angle. This one I think is a bit easier to understand visually because it's just the angle of a bat relative to a horizontal line in the seconds before contact. You see it all the time when you're watching a normal broadcast view. The name I always think of here is Joey Votto. Presumably had a very steep vertical bat angle. He always ran really low infield fly ball rates. He fouled off a bunch of pitches. Freddie Freeman is a good one too. He has the second steepest tilt in Major League Baseball right now, right next to Riley Green. You also see James Wood and Spencer Torkelson as pretty steep VBA guys as well. Some of the flattest tilt or vertical bat angles are Alejandro Kirk, Jake Berger, and Anthony Santander. I kind of wonder whether this is a way for us to put a number on adjustability of a given hitter. For example, if you look at pitches at the top of the zone and compare them to the bottom of the zone, the average hitter will steepen their vertical bat angle about 7 degrees to cover those pitches down. Again, they're adjusting to get to the low pitch. And I think connected to that, you'll also see attack angle steepen or upswing by about 5.5 degrees more. But there are some oddities to this as well. Juan Soto's attack angle actually flattens out on pitches low in the zone by about 2 degrees. He's only one of a handful of hitters to do this. There's also a group of hitters, including James Wood and Max Muncy, who steepen their attack angle a ton on pitches down in the zone relative to average. Basically, they have a lot more upswing on pitches down in the zone relative to the average hitter. So I know I was mixing vertical bat angle and tilt, or the relationship between the two, over the last couple minutes of this video. But if you're walking away from this with one thing, I think it's the relationship between tilt, which I think is one of the most important metrics in this release, and bat speed. I heard Eno Saris and Jed Lowry talking about this on their Rates and Barrels podcast. It was a great point. Basically, as you tilt down more, you're fighting gravity, so it's harder to maintain bat speed. This passes the sniff test too. These two columns I'm showing are bat speed and tilt. When I sort by the flattest tilt, look at how literally 15 of the top 15 hitters are above average in bat speed. And then when I flip to steeper tilt or vertical bat angle, there's a lot more blue in this bat speed column. Just 8 of the top 15 guys here are above average in bat speed. I actually had a convo the other day with a former sports performance director in a major league org, and we were talking about mass and its conversion to power, whether it be in pitching or hitting. And he said that while the correlation there is strong either way, generally adding lean mass is going to jolt up your power output, for hitters, he thought the correlation was stronger than with pitchers. For example, he was more confident than what your bat speed would be by adding 10 pounds of lean mass than he was in the velocity of a pitcher off the mound. I say this because when we look at the top bat speed guys relative to their tilt, it's a bunch of big dudes. Aaron Judge, James Wood, Ryan McMahon, etc. Mass, in the case of hitters who are in pretty good shape, is helping them to maintain their bat speed as they lower their tilt. So I guess if you're a hitter, get on MyFitnessPal and make sure you're in a calorie surplus. Bulk up. Another thing that kind of jumped out to me is that it also seems like tilt is not the easiest thing to change. In a sample of about 200 hitters who took 10 swings on middle four-seam fastballs this year and last year, over 90% of those hitters didn't change their tilt by more than 2 degrees, which is basically insignificant. Here's a list of 8 names who steepen their tilt by over 2 degrees compared to last season. Spencer Torkelson is probably the most interesting name here given his breakout, and then we have guys who have flattened out their swings the most. A pair of Angels here, kind of wonder whether that's a hitting coach thing, a change in their strategy. So I think this tilt number is a very nice addition to the suite of tools we have to analyze hitters, especially if you control for location or just look at middle four-seam fastballs and see how steep or flat a guy is overall. Attack angle, contact point, maybe more timing based, maybe more pitch type and location based. But if you're looking at hitters, trying to analyze who's going to break out, you're probably looking for a combination of above average bat speed, steeper than average tilt, decent swing decisions, so not chasing a ton, and contact. And I get it, that is probably your 1-1 prospect, a guy like Roman Anthony, etc., doing all those things really well. The more interesting discussions, which I won't get into in this video, probably come back to which of those is easiest to adjust. So you could see how something like this sums up into a pitching plan versus a specific team, or at least informs a pitcher's approach decisions against a hitter with, say, a flatter VBA versus one with a steeper VBA. A lot of this information is getting at the why. Why does a hitter create damage versus certain shapes and not others? And I think this is a lot more valuable from a confidence standpoint than just looking at the last 10 balls in play versus cutters and being like, this guy crushes that pitch. Steven Sutton Brown had a great tweet on this as well, pointing out how we can actually use tilt relative to a hitter's average swing on middle fastballs to back into what a hitter thought a pitch would be, which then allows us to determine what the hitter expected the movement of the pitch to be relative to what it actually was. We've had some attempts to quantify unexpected movement in the past, but they've all been mostly off the pitcher input. So arm angle and vertical break and release, etc., body size. That allows us to see, okay, this guy's four-seam fastball is a bit unexpected in how much hop it has. But I wonder whether layering in some of this hitting data now, swing, tilt, etc., building what the hitter thought the expectation was or where that pitch would be, is going to allow us to capture some guys who maybe have average expected movement from a ball flight standpoint, but the hitters are telling us, hey, we don't see this ball or expect it to be in a certain spot for whatever reason. Contact point or attack direction is another metric here, the third of these pillars. We can view this one from the front of the plate or relative to the hitter's center of mass. Here's a board of the hitters that make deep contact on average. Paul Goldschmidt, George Springer, Juan Soto, all pretty good names here. And then we can flip to see guys who make their most contact out in front of their body. We're looking at guys like Corbin Carroll, Isaac Paredes, Ellie De La Cruz. This one is cool because I think it does a lot to inform us about how to apply the principles we know about bat speed to hitters. Contact point, for the most part, is really a timing metric. Fastballs will be hit deeper in the zone relative to a hitter's center of mass, and anything slower than a fastball will mostly be hit out in front of the plate. One thing you'll hear a lot on broadcasts is see the ball deep, or wow, he let the ball travel, look at that swing, look at how deep his contact is. And I think that's mostly a cue that hitters are getting at, analysts are getting at. Let me think, see the ball deep, when in reality, what we see is that in order to actually do productive damage on balls deep in the zone, you have to have really good bat speed. So I think a lot of this point of contact data will help us inform the differences between cues and the reality of, hey, a lot of hitters probably shouldn't be seeing the ball so deep in the zone because they either A, can't create loft on the pitch, or B, don't have the bat speed to be able to time things up and actually barrel that ball. It's better for them to try to catch pitches out in front. So I looked at the 20% deepest point of contact balls relative to a hitter's center of mass this season. It's about 7,000 balls in play or so. And I sorted for the hitters who have barreled the ball the most, this deep in the zone, with at least 20 balls in play. And I gotta say, I really like this list. It's Shohei Ohtani, Corbin Carroll, Spencer Torkelson, Bryce Harper, Willy Adames, Dylan Cruz. Now, the average barrel rate on balls this deep is like 3% with a negative launch angle. So most of the time, hitters are just pounding the ball into the ground when it's this deep. And we're working with pretty small samples here, but I still think it paints a pretty good picture of guys who can loft the ball deep and hit it hard. Put another way, they can actually do damage on balls they let travel. So I know this is a lot of information. I hope you can glean something from it. My attempt here was to put something on YouTube that is related to all this information, because I do feel like a lot of the time what people do is write stuff off of this, but I hope visually and listening to me kind of talk it through unearths your brain in various directions. This is something that's going to take a lot of time even for me to digest, and I'm very fascinated to see who else in the industry unearths really cool information and what tools people create to allow us to digest this information more easily. But shout out to Mike Petriello, Tom Tango, Alex Fast, everyone else at Statcast. I actually got an early peek at some of this. I just wasn't totally confident in the info I saw to build a video ahead of time, so I had to wait a couple days until things actually dropped. As always, thanks for watching.